Power source was connected to the microcontroller by attaching the 5-volt output to the board's 5-volt pin and the negative side to ground, so the whole circuit shared common ground. We also stated that each LED was mapped to a specific digital pin. For example, LEDs were assigned to pins D2 through D11, and each one was connected in series with 220 ohms resistor to prevent damage.
The long leg of each LED was connected to its assigned pin through the resistor, while the short leg was connected to the ground. We added that the microcontroller was configured so these pins operates as output, allowing the LEDs to turn on when the pin was set to high and turn off rather when it was set to low.
Our LED dancing light project uses Arduino programming to control 10 LEDs connected to digital pins D2 to D11. To make the code organized and efficient, we store all LED pin numbers inside an array INT LEDs 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This lets us control each LED using a loop instead of declaring 10 separate variables. In the setup function, we run a for loop to set all these pins as output pins. For INT, I equals 0, I 10, I plus plus, pin mode, LEDs, I output. Inside the loop function, we call 10 different functions, each one representing a unique LED effect. The loop only contains 10 lines, but each line triggers an entire lightning animation, for example, running left, running right, ping pong. When each function is called, the Arduino jumps to the part of the code, executes the effect, and then returns to the main loop. This is an example of modular programming, which makes the code cleaner and easier to understand. Logic behind the 10 unique effects. Each effect uses combination of loops to repeat patterns. Digital write to turn LEDs on or off. Delay to control speed. Array indexing to refer to specific LEDs.
Programming concept use 1. Digital I/O pins. LEDs are connected to digital pins configured as output. We use digital write, open parenthesis, pin, comma, high and low, close parenthesis, to control the LEDs. 2. Loops. For loops, open parenthesis, for open parenthesis, int I equals 0, semicolon, less than 10, semicolon, I plus plus, double, close parenthesis, repeats task automatically. Helper for sweeping, animation, flashing, and patterns. 3. Delays. Delay time pauses the program to control LED timing. Without delays, the LEDs would blink too fast for the human eye to see. 4. Functions. We use separate functions for each effect, makes the code organized, easy to edit or add new patterns. Avoid writing long, repetitive code inside loop. Example, running left, close open parenthesis, semicolon. Randomly, close open parenthesis, semicolon. Silence scanner, close open parenthesis, semicolon. These functions act like mini light shows that the main loop plays in order.
we encountered during the activity, of course, are groupings helping each other to get the wiring right and the coding right. I mean, we help each other in the group if one of us is having trouble with the code. We give each other ideas then when the others have difficulty with the wiring. The others give each other ideas to fix the wiring.
We solve the challenges by helping each other. Like I said, we work as a team, not just one person. There were times when our work didn't work, but with the help of other members of the group, we solved it. Like when there was LED in the wiring that wasn't work, they suggested replacing it in another LED and it worked.